You mean this guy here, number 2, the one over root 11?
Yeah, we can start with that one and then maybe go to 4.
Okay, so this one here we just multiply with the root, the root 11 itself. We don't have to put negative or positive, just root 11, so that we'll have root 11, then down root 11 times root 11, just that's an 11. It's the same thing that we do on the first one as well. They're the same thing, just multiply with the root 5 here, even here root 5. The answer will just be root 5 over 5.
Okay.
Yeah, then for number 3, we just reduce them because we're having a what? We're having a root 12 over root 48. Okay, so root 12 over root 48. So the guy on top is the same as 4 by 3. And down again we have what is it? 16 by 3. That's going to be root 4 and root 3. That's going to be root 16 and root 3. So this cancels because of the same thing. That's going to be 2 over this. No. This is going to be a 4 here, right? The root of 16 is a 4. So
it is 4 here.
Yeah, it ends up being half.
Okay.
Yeah, that's what we get.
That's okay.
That's okay. Yeah, so this is what we have. Then the next one again, the next one is just asking us to simplify it. So we'll break down the 20. The 20, that's going to give us what? That's going to give us, we have a 4. So this is going to be root 4 root 5. So root 4 root 5, that's going to give us 2 root 5. Yeah, this is going to be 2. This is the same as 4 by 6. That's it. Root 4, that's a 2. Then there is a root 6 that remains. So this is going to be root 6. This here is the same as, we say what? We say 8 by what? 8 by 10. That's 2 by 5. This is a 16. So 16 is 4 root 5. Yeah, so like terms are just these two, which is going to be negative 2 root 5, then plus a 4 root 6. These are not like terms. We just leave it here.
Okay.
Yeah, so it's the same in the last one. The last one we're just multiplying by root 2, so meaning it will be root what? It will be 3 root 2, then the other one will be root 10. There's nothing we can do from there. They're not like terms, so just have it the way it is.
Okay.
Yeah.
For number 12, when it has a square, are you able to just remind me how to rationalize that?
For number 12, we just expand
we can
the
get
bottom
anyone
part.
with a square.
Okay, these are the same. Let me take this one that has a 5. So we have there's 1, there's a 5 plus root of 2, then there's a 2 this side. So just multiply the down part, 5 plus root 2 times itself. Yeah, this is 1, this is 25, 5 root 2, then 5 root 2, then plus a 2. Then the down part is going to be a 27 plus 10 root 2. Then here now again rationalize 27 minus 10 root 2. Yeah, this is what we have. It's okay? Yeah, we'll finish.
Okay, that's fine.
It's fine? Okay, I'll finish it off. That's 27 squared. Yeah, then minus what? 10 by 2, that's 100. 10 and 10, that's 100, then with a 2, so this was supposed to be 100 and a 2. Yeah, so we finish it off here. Which other one? This. So that's how we do everything here. Number 13 is the same, we just rationalize, right?
Yeah.
Yeah, which other
okay,
one?
So maybe 16, yeah, I would just go through 16,
Okay.
especially 1 and 2, I think. Anyway, what's the basic concept here?
or number 16?
Yeah.
Okay, so on 16 modulus, they're saying write down the values of this. The modulus of 3 over 5.
Okay.
So this is the same as only accepting positive numbers. So the modulus of 3 over 5 is just going to be 3 over 5. Just anything that comes out of this has to be positive. So this guy here will be 0.28. Yeah, this was supposed to be negative 8. It just comes out as 8. So everything, just solve everything inside normally. Then what comes outside has to be positive. That's what we mean by this.
Okay. So this is different from those equations that they will give you, which you have to kind of equate it to plus or minus something. I don't know if you know.
Oh, yeah.
Like when they have those two, it's different.
Yeah, this is different. Because those are equations, but these are just like numbers. So just deal with these directly. Just the number has to come out as positive. Like the last guy here, we have to do it in parts. There is modulus of negative 2. That's just going to be 2. There's a negative minus 3 outside. Then we have the down part, modulus of 6, negative 6, that's just 6, minus modulus of negative 8, that's just 8. Then there are these big moduluses. Yeah, so we have negative 1 on top, we have negative 2 down, modulus of half. This is just going to be half.
Okay.
Yeah, that's what we
have. Okay. Which one is this? Maybe we can go to 18.
Question number 18. Number 18 is on complex numbers, right? Yeah, so under complex numbers, the basic thing is that if I give us a complex number is anything that has the real part and the imaginary part. Let's say we have this. I squared generally is equal to negative 1. And if I ask us to say what is z bar means conjugate, meaning change the sign of the imaginary part. If I ask for z modulus, this means the conjugate. That's a squared and b squared. Then if I ask for z bar squared, this is just a squared and b squared. This is a general idea about complex numbers. Now, when we just do our applications, here, the first thing here is reducing these i's. So like I to the power 8, if the number is an even number, like I to the power 8, we can reduce the number using 2 because we know to say, we have what? We know to say this is the same as I squared to the power 4. So this is the same as negative 1 to the power 4. This just becomes a 1. This is okay. So if we have this, if we have this part here, we can do the same for big expressions as well, like this part here, like I to the power 42. I to the power 42 is the same as I to the power 2, because 42 is divisible by 2. That's going to give us what? 21. Now negative 1 to the power 21. 21 is an odd number, so this is just going to be a negative 1 still. That's okay, right? Yeah, so that's what we basically have. So the same applies if the number is odd, like the 105, we can just break it down to be I to the power 105. This is the same as I 104, then I here, so that we are able to say the 104 can be broken down to be I squared. That's a 52. 104 divided by 2, then we have I waiting outside. This is negative 1 to the power 52, which is simply 1. So the answer will just be I. It's like I give you I to the power 3. When the number is odd, you reduce it, you write it as 1 I, and the other thing that remains, because when you add it gives us back 3. Then this is negative 1 times I. This is just goes to be negative I. So we have something like this.
I see.
Yeah. It's okay, right?
Yeah, it's okay.
Yeah, so that's what we have.
Okay. And 19, let's see, 19, yeah, 19, especially the first one, I think.
So for 19, we're using the same skill again. Yeah, so here we're having we're having 3i to the power 5, and we're having this part here. So we break down all the i's, all these powers there. So we break them down, yeah, to be something that we should be able to handle.
Okay.
This is going to be, rewrite it, that's a 3i to the power 5, then what, minus what? I to the power 4.
3i to the power 5 minus I to the power 4 plus 7i to the power 3.
Plus 7i to the power 3.
Minus I squared minus 9.
Minus 10i squared minus 9. Minus 10i squared minus 9. Yeah, so this part, the I to the power 5, we can just simplify it by the side. This is I to the power 4. And then I, this is going to be negative 1 to the power 2. There's an I. This is going to be, it's like negative I times negative 1, because it's I squared and I squared, right? The 4. So it's negative 1 times negative 1. So I to the power 5 is the same as I. That's okay, right?
Yeah. Okay. Wait. I to the power 5 is the same as I. Oh, yeah. No.
Yes. Yeah, so that's what we have. So now this part here, we're going to have 3i because we reduced it. Then I to the power 4 is the same as 1. So I'll write a 1 there. I to the power 3 is the same as negative I. Excuse, this is where the negative 7i is going to come from. I squared is the same as negative 1. So negative 1 times negative 10, that's going to be positive 10. Then we have a minus 9. The like terms, the guys with the I, that's going to give us a negative 4i. Then we're having 10 minus 9, that's a 1. 1 plus negative 1, it disappears. So we're getting this part there. That's okay. Yeah, so that's what we get.
Okay.
Then the next one as well will be done in a similar. We'll reduce everything. So again here, we'll change everything. So I'll leave the 5. It will be 5 over I. The I is still simple. 2. I to the power 3 is the same as negative I minus 20. I to the power 18. So I to the power 18 is the same as I squared with a 9. This is the same as negative 1 to the power 9. The answer is just negative 1. Yeah, so this is just negative 1 down there. So I'll write it as 5i minus 2 over I. Then this is plus 20 over 1. So this here is just going to be, the common denominator is simply I squared, because I've multiplied I times 1. Then I'm going to be doing I times I into I squared. That's going to be I. So hope you're okay if I say it's 5i, then minus 2i plus 20i squared. Is this part okay?
I into I squared is I.
Yes, because there's one I that remains, right? Yes, because kailima I ni abiri, so kwangenamu I moles, so meaning kuzasala I moles. Yeah. It's okay?
Yeah, that's fine.
Okay. So if that's okay, then we can proceed with writing the top part. So the top part is going to be the same as 5i minus 3i, that's going minus 2i, that's going to give us 3i. 20i squared is the same as negative 20. Then panyans pali I squared the same nga pali negative 1. So we can now reduce everything here to be what? To be negative 3i, then plus what? Plus 20. That's okay.
Yep.
Yeah, so we can just rearrange it into having your what? Having your 20 minus 3i. Everything is still the same. We prefer putting the real part first before before the other guy is. Yeah, so that's the same thing that we also do for the last one. I know there's this guy that does a negative power, so let me just show you how we do it. This is supposed to be 2i to the power 6. Then we are having but there's a plus 2 over I. This is raised to the power 3. Then plus 5 to the power negative 5. I to the power negative 5. And the last one is negative 12i. Negative 12i. Yeah. So this here is going to be I to the power 6 is the same as what? Are you okay if I say it's negative 1? Because it's I to the power 6. So kuzankala I squared, I squared and I squared. So this is a negative 1 and a negative 1 and another negative 1. That's positive. Then we have that guy. So we have this part here. Then this middle part, the second term, we have 2 to the power 3. That's going to be 8. We have I to the power 3. It's the same as negative I. Then here, for the sake of solving, we're going to change this to be, this part is the same as I to the power 5, right? Yeah, so if you're okay with this, meaning we can just change what is I to the power, this is the same as 8 over I, then plus 5, what is I to the power 5? I to the power 5 is the same as I squared and I squared and I, this is positive 1. So I have an I there, minus 2 of I over 1, this is over 1. Again, we do the same thing. It's like 1 times I times I times 1. The common denominator is I squared. Yeah, so again, we do the same thing that we did previously. This is going to be 8i plus 5i. Then minus, there's already a 12i. We're multiplying it with another I squared. So this becomes positive 2. This is negative 3i because these two are like terms. Negative 1 times negative 12i will be positive 12i. Down is a negative 1. On top, you have what? 12 minus 3, that's a 9i, plus 2 over negative 1. This ends up being negative this, which is negative 2 minus 9i. Is this okay?
Yeah.
Yeah, so that's what we have.
Okay. For 21, what do they mean? Well, I understand the whole modulus thing, but in this situation, what do you mean? They say find the modulus of the following complex numbers.
Oh, okay. So since we already know what the modulus means, it's just like squaring the root part and the other part. So, okay, 20, you're okay with expressing it in the form of A plus IB, right? 20, okay?
Yeah, I think so.
Okay, so now on 21, when they want the modulus, like this one here is straightforward because they say I minus, the original question where they got it from was I minus 1, that's the correct question. Because here it will give us a 0, I minus I is 0, 0 squared is 0, so modulus of a 0 is just 0. But let me give you this one here, I think is the best one. Yeah, so when they say what? When they say, let me open it here on the phone so that it's easier. So once it's the same thing like the previous question, you first of all have to put it in the form of what? In the form of a plus ib. That's what you need to do, because when you are done doing that, then you'll be able to get the modulus, because modulus needs us to be able to use the a and the b. Yeah, so let me just put it up here, just a minute. Okay, opened it. Okay, so this is what? This is 2 minus I. Then there is a minus 4. 1 plus 1 over 4 I. So this is the same as 2 minus I minus 4, then minus 4 and 4 cancels to give us I. So this here is the same as negative 2 minus 2I. You're okay with this part, right? We multiplied the 4 times the 1, that's the 4 there. The 4 times 1 over 4, so 4 and 4 cancelled to give us negative I. That's what we got there. Is this part okay?
Hello.
Hello, you're able to see the board, right?
Yeah, you're able to hear me now?
Yes, I'm able to hear you now. Is this okay up to how we're reaching here?
Yes, so before you even said something that I was asking something, but I think you haven't been able to hear me.
Okay, what was your question?
Yeah, I was asking to say there's a difference between 1920, right? Here it says expressing it in form of A plus BI. This other one is A plus IB. So there's a difference?
Yes, there is you're saying what, 20 into what? You're saying number 20, this one, and what, 21, getting the modulus?
No, 19 and 20. So you're from okay with 20. And I just realized
it's the
there's
same.
a difference.
The same one. Write the following powers. Write the following it's the same. So here they are saying the powers have to be reduced as well, because here we had things that had bigger powers. Here there's nothing that has a bigger power. It's just expressing, like rationalizing or conjugating, adding them up. Yeah. So here they wanted us to reduce the powers first, then express them in A plus IB. So it's just one and the same.
Okay.
Yeah. Then now.
Okay. So I can't see your screen. I don't know if it's on my end.
Oh yeah.
But it says you're presenting.
Yeah, it's on your end. Try to rejoin. On my end, it's perfect.
Okay. Oh, I can see it now.
So after we got our expression, this is what we did. We expressed in the form of A plus BI. From here now we get the modulus, which is going to be negative 2 squared plus negative 2 squared. So this is going to be a 4 plus a 4. This is the same as root of 8. This is 2 root 2. Is this okay?
1 second, just cut it. Okay.
Yeah, so that's what they mean by modulus. So put the expression first in the form of this, then I'll get the modulus of this, which is A squared plus the B squared, and finish it off. That's all.
Okay.
Yeah, so that's what they want for all questions. Even here, it's the same thing. Rationalize it, multiply by 3 plus 4i. So 3 plus 4i. Then once you get your A and your B, then find the root, the modulus of whatever you're going to get. That's your number 21. Then look at number 20 is number 22 is the same thing, except here we're just dealing with arbitrary letters, because z is what? X plus I, y. So they want us to get the modulus of z. Pali z, we put x plus I, y. There's a minus I already, and a minus 3i. Then there's this. This is going to be the real part. This is supposed to be x plus iy, this is minus 4i, because it's negative I and negative 3, so they're like terms. They'll give us this. There's a 2 there. Then from here we have x plus, there's y minus 4, and there's an I squared. Yeah, so it's like modular squared. We said whenever there is this, remember we said z squared is the same as the real part only. The real part, x squared, and the imaginary part, that's without the square root. Because palikudala 2 but the square root was cancelled. Remember the summary I gave you. Look at the difference. You remember this guy here and this guy here. Yeah, so we are dealing with this part. Our question is this part, so we just need to get the real part and the imaginary part squared. So that's what we're going to do. Solving from here, right? Okay, yeah. So the real part is x. I'll remove this bar, so this is going to be plus the y minus 4, the imaginary part squared. That's all, just end there. That's what they want.
Okay. So you don't need to start. See, that's x squared plus y. That's how you're gonna start 4.
Which one?
In brackets there, x squared plus
y minus 4. Yes, plus y minus 4 squared as well.
So you don't need to start expanding that.
No need of expanding it. Just leave it the way it is.
Okay. All right.
Yeah, so that's what we have. Then apart from this, we have, it's the same thing even the next one, except for the next one, we need the conjugate. The conjugate of z, because I said it's, here now it's actual modulus because there's no cut2 there. So it's going to be, I can replace it directly, x, z is this, then plus 5. The modulus is x minus iy. And put it like that, then evaluate what you have there. It's going to be x plus iy plus 5x minus 5iy. This is equal to x plus 5x plus iy, then minus 5iy. This is equal to, we have 6x, then subtract this, we get a negative 4iy. Then from here we have the real part is 6x squared plus the imaginary part is negative 4y squared. Just leave it there. Maybe you can just leave it here as 36x squared plus 16y squared, but just leave it there.
Okay, so what you're saying is that for this, what's this? Where is it? This was like, I don't know if you put z bar 5z there.
Yes.
With the thing on top. So when you have that, you're saying they're asking for the conjugate of z, which is x minus iy.
Yes, now we're replacing it with the conjugate, yes.
Okay.
Yeah.
Okay, so when I see that, that means conjugate?
Yes, that means the conjugate, yes.
Okay.
So number 23 and 25 are almost the same. We're going to do, okay, I'll do both still, but because they're different, this gives us simultaneous equation. Here we need substitution. So number 23, we're just going to expand. They're saying this times that is equal to that, where x and y are real numbers. So for x and y, they like this equation. Yeah, so we have, let me put it up here. Yeah, so we are having, here we're having a 2 plus iy. Then we have x plus what? Is it a 1 there or I? I think it should be I. This
That's
is
I.
Yeah, 1 plus 3i. So we multiply 2 with everything. So that's going to be 2x plus 2i. And then this by that, that's going to be xyi minus y is equal to 1 plus 3i. Yeah, you're okay with how the minus came about, right?
Yeah, because of the I squared, which is equal to -1.
Yes.
Yeah.
Yeah. So now when we reach here, we're going to equate the real parts. So, and the imaginary parts as well. So the real part, we have 2x, things without x, that's going, without I mean, so that's going to be this, is equal to 1. Then things with I, but don't get the I, just get the things, like a 2 there, there's a 2, then there is xy, then there is equal to a 3. Yeah, so from here now, we can solve. This is not going to be simultaneous because here the x and the y are attached. They are together. So I can just take the 2 on the other side to be 3 minus 2. This is xy is equal to 1. Yeah, so I'm going to make y the subject there. Y is equal to 1 over x. So that I can replace in the first formula. First formula, which is just the same as 2x minus, where there's y, I can put 1 over x is equal to 1. Then from here now, I can do up the common denominator, which is what? Which is x. Then I'm going to have 2x squared minus 1 is equal to 1. Cross multiply, 2x squared minus 1 is equal to x. Then 2x squared minus 1 minus x is equal to 0. So 2x squared minus x minus 1 is equal to that. I'm going to solve for x here. The product, that's going to be -2. The sum is a -1. The factors are what? We can use what? What factors can we use? -2 and 1.
It is what? -2?
Yeah,
we can't see that.
This is -2. We are having this guy. Yeah, so the product is -2. The sum is -1. So the factors are just -2 and 1, right?
Yeah.
Yeah, so we can just get this. Then -1 is equal to 0. We have 2x. Then there's an x minus 1. Plus 1, and there's an x minus 1 is equal to 0. 2x plus 1, then there's an x minus 1 is equal to 0. When you solve this, you get x is equal to -half, then there's an x is equal to 1. So we have this part and we have this part there. So we already said y is equal to 1 over x, meaning wherever there's x, we can replace with these two values. So when x is equal to 1, y is also going to be 1 when I put 1 there on my x. Then when x is equal to -half, so 1 over -half, the answer is 2. So y is equal to 2. So I have these two pairs. You've seen them, right? Yeah, so this answers our question. We have two pairs. So we have z can take two forms. They can be when x is 1, so that's simply 1 plus I1 because they're both 1, or when x is equal to -half, then we have this. So z can either be that or be that.
Okay.
Yeah.
So when showing it, where do you end, or how do you just end there, or do you like conclude in a certain way?
So in this case, since we wanted to conclude for, okay, let me raise this guy. So here when they say what, where is, or they just say so for x. Yeah, so you say x is equal to 1. 4, you just say 4, x is equal to 1, y is equal to 1. For x is equal to -half, y is equal to 2. Give them like this.
Alright.
So it's the same thing, even the last one, we multiply. So the last one, they just said z is a plus ib. So where there is z here, we're going to put a plus bi and equate it to 7 plus I. Then multiply, or rather expand the left hand side. The same thing that we did. Yeah, so we expand everything this side. So this is the same as plus I. So expand everything here to be 2a plus 2bi plus 3ia minus 3b is equal to 7 plus I. Then equate the real thing, so I'll leave you this as a task. Let me just solve for you number 24. That's okay? Yeah, so number 24, we have this part here. These are just modulus. So I should have added something on when we're doing this. If I give you modulus of, okay, I already said that modulus, but if I give you a complex number, let's say 2i in a modulus, this is just going to be 2. A number in a modulus, we've already talked about it. You let it be positive when it's coming out, right? Yeah, that's the whole idea of modulus. So it's the same thing we're going to use here. Yeah, so they want us to get, there's a modulus of what? There's the question is here. Modulus of z plus 4i there, then this is equal to 2, modulus of z plus I. So we're going to split the modulus symbol here. This is z, by the way, not 2. Yeah, so modulus of z plus modulus of 4i is equal to 2, open brackets. There's a modulus of z plus modulus of I. Yeah, so this is just still going to be z. This is just a 4. That's the rule, according to the rule. Then here you have 2 modulus z. Then this is a 1. Modulus of I is just 1 because the coefficient is 1. So 2 times 1, that's where the 2 is going to come from. Then from here we gather like terms. It will be 4 minus 2 is equal to 2 modulus of z minus a modulus of z. So this is 2 is equal to modulus of z. So this answers your question number 23. So we just distributed the modulus. We just shared it.
Okay, so you're saying modulus of I is 1?
Yes, because of the rule
so
here.
It's 1.
Yeah, because the rule here says modulus of anything with I is just that same thing. So okay. Yeah, I has a 1, so now we're just saying it's a 1.
Yeah.
So this answers the whole lot of tutorial sheet 1. This is okay, right?
Yeah, that's fine.
Okay.